Having this on-demand self-service rapidly elastic model that is cloud allows us to do wonderful things that we can do, and the many good things with good honest software that we couldn't do in the past. However, all of those attributes allows evil actors to do some pretty malicious things as well. So for an example, cloud resources are enormously effective at mounting DDoS attack. If you can go in there and spin up as many as resources as you like, as fast as you like, that is enormously useful for flooding a target with malicious traffic. You can spin up a bunch of machine in one go, and you tell them all the target of a particular resources. Now that the claim providers such as Microsoft and Amazon and Google normally put a stop to the sort of thing, when stop it pretty much quickly, but now all cloud providers are quite so vigilant, and indeed it can also take a while to before malicious activity like that is identified and service shut down. For another years again is for password tracking. This is an activity which you can be really research intensive, and the upside of doing this is the cloud that appropriate resources can be provisioned when required, used for the duration and for the cracking process, and then simply discarded and the charges. And then again, this is the joy of having measured service. Let me give you an example of that. In 2015, there was a piece tracking with Wi-Fi WPA2 password thanks to Amazon, and effectively what they have done is just spun up the appropriate resources as required and then gone through the password cracking exercise. So in this case, there is a perfect image already available in AWS and Amazon Linux AMI and NVIDIA Grid GPU power. So this is now using graphical processing unit that are available as a service in the cloud, and then they tend to be enormously effective at cracking certain types of hashes. Now of course, password tracking isn't always used for malicious purpose, but you can certainly see how it would be attractive to attackers. So that wanted to, and the attackers that wanted to use the cloud to break others people's security. So let's go and have a look at another malicious who use button and it command and control in a botnet, botnet CNC and botnet of infected machine, sometimes tens of thousands of different machine. The commanding control server gives the attacker a mechanism to detect the behavior of the bots. Now these CNC servers always the target of law enforcement and security vendors are like this. As an example, if you can take down the CNC efficiently and leave the infected machine, and then it can no longer take commands from anywhere. So part of the joy of that cloud for but harder who's trying to keep their CNC server alive. Now CNC environment, of course, let's just gonna do make sure and that those infected clients know which CNC server to talk to, but the very fact that they can spin up machines so quickly and then spin up them again in different parts of the world with different configuration gives them a whole bunch of different options which they never had before. In this advent of the cloud, one final malicious use for the cloud is CAPTCHA solving. Now this is an exercise which is done by various levels of success depending on the CAPTCHA and depending on the value of solving an individual one of their attacker. This is an exercise that can be quite resource intensive, particularly if it is done at volume. So the promise of the cloud here is the ability to rapidly deploy instance of logical machines or services that can take a board or load involved in tracking captcha. Now an automated machine solving captcha for you probably sounds like a pretty nice idea, but keep in mind the captcha are normally there to try to avoid automation. So this usually there to protect the system from attacks such as brute force. So in attack of being able to solve the captcha at a higher rate often than puts other legitimate machine at risk. These are all malicious users of the cloud that we have seen before, and we will see them again as well. So let's go and take a look at couple of other potential risks within the cloud. So let's start here, and it's a very question that many organizations are asking themselves. What does it mean they cannot control the physical machine? Does it increase the risk? As I have said many times now, I actually don't think this is a good question. It's a very black and white, and it's a like a black and white question. Is it more risky or less risky? Because you could ask this question instead. So is it possible that the cloud provider could manage the infrastructure better than what the organization themselves could? That goes back to one of the points that made in the very first lecture, where I showed you the use of these Google data centers are and how they are able to commoditize the way these resources are managed and do in a very professional manner. So again, just saying, is it more or less secure? Is the risk increased or decreased is perhaps not the right question, but let's actually touch on that concern I raised in the last slide. What can possibly happen if you are sharing infrastructure to someone else? We looked at hypervision breakouts earlier on. So let's look at the another risk related to sharing underlying infrastructure in 2015. So when this attack emerges, this has become known as row hammer, and what we are talking about here is a very low level attack that goes all the way down to the way dynamic and random access memory. So memory was also known as DRAM, where could possibly leak charges, and as Wikipedia says, here interact electrically between memory cells and possibly altering the contents of nearby memory rows that were not addressed in the original memory access. The bottom line is that row hammer can potentially change the state of the memory outside and the intended function of the process that's using it, as an article goes on to explain here. We actually saw that used in some of the privilege escalation exploits. Now think about this from the perspective of a cloud, and in fact think back to when I talked about the high providers. Row hammer is an attack against the underlying physical infrastructure, not the logical infrastructure or anything else, which is isolated by the hypervisor. This is precisely the sort of things that organizations are worried about when they share the infrastructure with other customers. Now I have included these down here as the end of this lecture. So in other potential risk, simply because of illustrate the fear of sharing that underlying physical infrastructure, there went a workable attack that were used to in this cloud environment that allowed one customer to start modifying or accessing another customer's. So certainly none that became publicly documented anyway, but that's the part of the concern. We know that the true potential with many of these experts to keep silent, and are used to malicious way that we never know about publicly, while there is a shared underlying physical infrastructure, and this is the sort of concern that opponents of cloud computing will raise. So let's look at one more, and this one is a little bit more hypothetical. In 2016, there is a study done that showed how crypto keys on a machine could be obtained by another machine and another room, and then first machine was air gap as well, so it was not connected to a network at all. Now what the researchers from Tel Aviv University found is that they could measure the targets by electromagnetic emanation, and that alone could possibly extract the crypto keys. This obviously requires some pretty specialized hardware, as you can see in the image that the bottom left here, and it did also require pretty close proximity between the equipment and the target machine, and it was just the other side of the wall, but it was significant that the machine was actually air gapped, and it was a very simple passive observation of how the machine was behaving. Now in fairness, relating this back to cloud computing, it's a very long bow to draw in. So far as what these guys were able to do is having any impact whatsoever on the way she ran the day onto cloud, but look at the problem this way. What many organizations are concerned about this when they no longer have physical control of this infrastructure. They become somewhat I would say xenophobic, and they are afraid of the unknown. Now whereas the raw hammer or specialized electromagnetic gear, looking at the emanation from the machine, this feels ability and these attackers is almost a secondary consideration, because the concern is simply that it's not within their control, and often the belief is that if those machines sit within an organization data center, it attacks like this simply won't happen. But of course there have been many attacks. The gas physical infrastructure that exists within an organization data center, and they might not be able to be the one who are looked in here, but they have been a such more classic style of attack, often attacking from things like malicious insider or actors who is socially engineer themselves onto the organization premise, and the different attacks, and this again speaks the whole premise of a cloud security being defined rather than better or worse. But one thing that does play into the favor of cloud security is that when we look into the cases of Gen hypervisor breakout, and that was a serious bug, it's now become someone else's responsibility. And all of the positive things about cloud security is that when you use a provider the size of Amazon, Google or Microsoft, they have an almost unparalleled ability to identify, patch and deploy defenses against this risk in record time, and that's a really good talking about the consideration in cloud computing or security strings. Now let's go and wrap this up, and we will go and look at the good security aspects of the cloud.